Hi, I am Vijay Lakshmi, Assistant Professor, Department of EEE, Nanda Engineering College. I am going to give the hands-on verification about the phase controlled converters. This converter is two pulse converter, that is single phase full controlled converter. So normal rectifier which converts fixed AC into fixed DC only, but this phase controlled rectifier using SCS which converts fixed AC into variable DC. So this converter is working with the R, RL and the RLE loads. Here we are going to analyze the comparison between the R and the RL loads, also with and without freewheeling diodes. This is the converter with R load. We have single phase 230 volt AC supply with 50 Hertz. This converter consists of 4 thyristor switches. For full converter consists of 4 converter switches. If it is half converter means we need to replace the 2 thyristor and 2 diodes. Instead of 4 thyristors we are using for half converter 2 thyristors and 2 diodes only. This is the full controlled converter, so we are considering 4 switches. From input half, every input half cycle, positive half cycle, T1 and T2 conducts. So Ig1, Ig2 pulses are given to the T1 and T2 switches. Every negative half cycle of the input supply, the T3, T4 will be conducting. The respective gate pulses are T3 and T4. If the value of alpha is here triggering as 30 degree, so the formula is theta divided by 360 into total time period. So here we are given 30 degree as gate pulses. So for T1 and T2, for T3 and T4, 180 plus alpha, that is 180, alpha is 30, so 180 plus 30, 210 divided by 360 into time period. So now we are going to simulate the output voltage and current waveform this converter is. So see, this is input waveform of AC supply, input waveform of the converter. This is the gate pulses of positive half cycle 30 degree triggering pulses. This is negative half cycle pulses. This is the output voltage waveform of the converter with the R load. From 0 to pi as positive half cycle, diode conducts from 0 to pi only, there is no variation, but by using SCS we have to vary in the output DC voltage by triggering the firing angle values. So this is alpha, from 0 to alpha as delay time, that is 30 degree. From alpha to pi, T1, T2 switches conducting. From pi to pi plus alpha again delay. Then from pi plus alpha to 2 pi, the T3, T4 switches conducting. So by the way, the switches are consecutively conducting from alpha to pi as T1 and T2, from pi plus alpha to 2 pi as T3 and T4. This is output voltage waveform. During R loads, at every half cycle, that is pi, 2 pi, 3 pi, the output voltage is 0, also the current also 0, but during RL loads, so this is the single phase full converter with the RL load. The output of the RL load is, see here, from alpha to pi, not pi, pi plus alpha, still pi plus alpha, the T1, T2 extension this voltage conduction at the reverse direction. Okay. So the single phase full control converter with RL load limits conduction starting from alpha to pi plus alpha, T1 and T2. From pi plus alpha to 2 pi plus alpha, T3, T4 conducts. This is the output current waveform. This current waveform may be continuous or discontinuous, depends on the inductor value. If we are choosing high inductance value, we will get the continuous conduction output current. So this is the comparison between R load and the RL loads. If we need to discharge this reverse voltage, we need to connect the diode parallel with the load. So this diode is called as freewheeling diode or flywheel diode. So this diode conducts every every half cycle from pi to pi plus alpha during positive half cycle, during negative half cycle from 2 pi to 2 pi plus alpha. See this waveform. So this is triggering alpha value as 120 degree, that is greater than 90 degree. From 0 to 120 as delay, this is alpha. From alpha to pi conducts, from pi to pi plus alpha, freewheeling diode conducts and discharges the reverse voltage. So it's look like as R load output waveforms. Okay. So this is the comparison between the R load and the RL load, as well as the with and without freewheeling diodes. One more key point is the single phase full controlled converter with RL load can be worked as in two modes. One is rectification mode and another one is inversion mode. From alpha to from 0 to 90 degree, it can be worked as a rectifier, that is power transferring from source to load side. The maximum power can be transferring from positive side. During 90 to 180 degrees, it can be act as a inversion mode inverter. That means the power can be transferring from load side to source side. The maximum power can be transferring from a reverse side. Okay. Thank you.